lesson, we're going to add and subtract radicals. It's actually pretty easy. It's just like adding polynomials, which I hope is not too crazy scary. We'll do some review ones together really quick. Okay, so if you were to add these polynomials, you always solve the things in the brackets first, and then you move on outside of the brackets, right? Inside this first set of brackets, there is nothing that you can simplify. Because the x's are on their own, the y's are on their own, and the constant is on its own. Those are all separate things. In the second set of brackets, there's nothing you can do. The x's are by themselves, the y's are by themselves, and the constant's by itself. They're all separate terms. There's no negative, so we're good. Now that you've solved everything in the brackets, which really was nothing, the brackets can go away. Because we've solved everything in the brackets. There was nothing to solve in this question. It's a really easy question. Nothing to solve in the question, so we can just get rid of the brackets. Now we combine like terms. That means we combine x's with x's, y's with y's, constants with constants. So what's 2x minus 3x? Negative 1x. What's negative 3y plus y? Negative 2y. What is 4 minus 3? Plus 1. Done. That's your answer. Easy peasy. Second one, we're going to do the same thing. Inside the first set of brackets, nothing we can simplify. Inside the second set of brackets, nothing we can simplify. But there is a negative right here. What do you have to do with that negative? You have to make it a positive. How do you make it a positive? You got it. So we make that a positive by changing all the signs inside the brackets. So the negative 2x became a positive, the 3y became a negative, and the 1 became a positive. Pretty easy. Okay. We've solved everything inside the brackets. We can get rid of those brackets, and now we combine like terms again. X's go with x's, y's go with y's, constants go with constants. Negative 4x plus 2x is negative 2x. Positive 5y minus 3y is positive 2y. 2 plus 1 is positive 3. Pretty easy. Last question. Now we actually have something we've got to do here. Inside the brackets, nothing we can simplify. It's 2 on the outside of the brackets. What do we do, Jacob? You got it. We distribute it into the brackets. So the 2 goes to every term. Meaning that you will have 2x plus 4y minus 4. The second one, what a lot of people do is they take the 3, they distribute it in, but they forget that the negative's there. Distribute your negative 3 in. It's not a positive 3, it's a negative 3. So negative 3 goes in, and it will become negative 3x. Negative 3 times negative y becomes positive 3y. Negative 3 times 1 is negative 3. And I put those ones still in brackets just to show you that all we did was we changed the symbol from negative to positive by changing all the other symbols. Okay, one more time on that one. I distributed the 3 in. So x became 3x, y became 3y, and the 1 became 3. And then I changed all the symbols because there was a negative, and I wanted it to be a positive. So all these became negative or switched to positive. Okay, combine all your like terms. 2x minus 3x is negative x. 4y plus 3y is plus 7y. And negative 4 minus 3 is negative 7. That should be quick. That should be automatic. That should be reviewed. Okay, radicals work the same way. The best way to look at it, this is my opinion, the square root of something. You can just call anything else like a letter. You can just give a letter to represent it, and it's easier to identify. So if you look here, they've taken a basic one, and they've combined like terms. But if you look at this, that's a like term, that's a like term, because they both have root 3 in them. If you called root 3 x, it would make sense, right? It would be x, and it would be 4x. See how they just combine? Same idea. X is just a root 3 here. They've just given it a number. Those are like terms because they're both times a root 3. So we can combine those. If you have 1 root 3 and you have 4 root 3s, how many do you have? 5 root 3s. So they made it 5 root 3. Plus 2 root 7 because you can't do anything with that 2 root 7. It's its own term. Root 7, you could give it a different letter. Root 7 could be y. See how you can't combine them? They're different things. Okay, so it has to have the same root, which means it also has to have the same index. So you can't combine square roots with cube roots.
So that number in front of it is common.
How many of them you have? Yeah. So that's why I say call them a variable, and then it's easier to picture, right? Like if root 3 was just x's, it would make easy sense. We have 1x and 4x. But really x is just root 3.
So you have to find the greatest common factor
For which one?
for any of the middle groups.
Yeah, I see what you're saying. We're going to get to those ones. Yeah. Because it's going to get harder. So this first one is nice and easy. We have 5 root 6s minus 2 root 6s. So how many do we have? 3 root 6s. 3 root 6. That's all you left. The next one's a lot harder. Because if you look at that thing, you should, I hope, look at it and go, we can't combine any of those. Those are all different terms. Could you break them down? Could you simplify them? Yes, you could, right? And you simplify them using our way of going from entire to mixed radicals. Meaning we need our perfect cube chart. Yeah, they have to be simplified to come out to be the same thing.
Yeah, but then say it's like for cube 2.
Yeah, it's a good way to look at it. You want to break it down to cube 2 then. Yeah. Okay, so to break these down, we use our perfect cube chart. Meaning 2 cubed is equal to 8. 3 cubed is equal to 27. 4 cubed is equal to 64. And that should be as far as we need to go. Look at this first one. 128 breaks up into 64 and 2. The cube root of 64 is 4. So the cube root of 128 can change to be 4 times the cube root of 2. We took 168, or 128, we broke it into 64 times 2. The cube root of 64 is 4. So it came outside of the thing. Okay, the next one. 16 is divisible by 8. We break 16 up into the cube root of 8 times 2. The cube root of 8 is 2. So this one is just minus 2 cube root 2. The last one, 54, divisible by 27. 54 we're going to break up into 27 times 2. The cube root of 27 is 3. So this one is minus 3 cube root 54. Sorry, that gets messy with it. That says 3 cube root 2. I put 54 in there. Should be 2. Oh. That's a lie. Yeah, I'm still just going with what I'm saying. So now they're all down to cube root 2. So now you can combine them. They're all like terms. You have a whole bunch of cube root 2's. You have 4 cube root 2's. You subtract 2 cube root 2's. And then you subtract another 3 cube root 2's. And you should have negative cube root 2. Just one left, and it's a negative. Logan. If you put the 1 on the outside like this, that's fine. Same thing. You will probably never see an answer with a 1 in front of it, but as long as you know that not having the 1 just means it's there still. Okay, let's try, I can't extend my page. Let's try the next one. We have square root of 20, square root of 18, square root of 45, and square root of 50. What chart do we need? Perfect squares. The perfect square chart. So, 2 squared is 4. 3 squared is 9. 4 squared is 16. And 5 squared is 25. We won't go any further than that because 36 I can't go into this. This first one, square root of 20. What can we break that into? Chase. Yeah, 4 and 5. I chose 4 because it's from our chart. So 20 can be broken up to be 4 times 5. The square root of 4 is 2. So this changes into 2 times the square root of 5. Plus. Square root 18. What do we think we can break that into? Anybody? Jacob? 9 and 2. So we can break 18 into 9 times 2. That came from our little chart over here. The square root of 9 is 3, so that means we have 3 square root 2 left over. The next one, 45. What can go into 45? Can 16 go into 45? No, 9 can, yep. 45 breaks into 9 times 5. Okay, so the square root of 9 is 3 times the root of 5 is still left over. And finally, the last one, 50 can break into 25 times 2. The square root of 25 is 5. So it becomes 5 square root 2. Now we need to combine like terms. If you're looking at that, I hope you see I can combine my root 5s and I can combine my root 2s. So the red lines go together and the green lines go together. And it simplifies to become 5 root 5. 5 root 5. And then negative 2 root 5. Oh, sorry. That's backwards. Yeah. That's wrong. Root 2. Wrong. You can see how concepts constantly are building on themselves. We started off with some review where we were just trying to take entire and change them to mix. And now we're using that skill to be able to combine radicals. That's how this course keeps growing. And that's actually how math is going to keep going through high school. It just keeps building. Yeah. Next slide. First one, what is it? Try it on your own. See if you can get the answer. I'll write the answer on the board. See if you can get it. If we look at it, you'll see I have 4 root x. They're already all in the root x form. Life is easy. Let's move on to B. Before you try combining things, try breaking them down. What's the square root of 25? 5. What's the square root of a squared? What's the square root of b? square root of b. You can't do anything to it. Plus, what's the square root of 4? What's the square root of a squared? A. And what's the square root of b? It's still square root of b. Great question. So now we've only in the past combined coefficients. But now we have a variable also in the front. So we're saying when you combine them, is it going to jump up and become a squared? Like how many a's are actually there? And the best way to think about it is just you have 5a and you have 2a, and they're still separate things. So if you ignored the b's for a second, it would become 7a, right? Still the same thing. So it still adds the same way. It won't become a squared when they combine. So you would have 7a root b. Yeah, that's tomorrow's lesson. Yes. Okay. This next one. Same thing. We're going to do it one at a time. What's the 4th root of 81? Punch in your calculator. See if that comes up to a nice answer or not.
3.
3. What's the 4th root of P3? It's still the 4th root of P3. It doesn't change. It can't simplify. So it's still going to be root P3. Fourth. Yeah, we're about to do the q's. What's the 4th root of Q5 going to be? 1q is going to come out, and then 1q is going to stay in. So it's going to be 1q in the front, and 4th root q is still right there. And those can combine to be at the same 4th root sign. I've left them separate right now, but I'm going to combine it for a second. So those of you who look at it like that, that makes sense. Good. I'm about to erase it and put it all under one root sign because it's evened out. So we have 3q, 4th root, P3q. Time.
What happened if, like, you did the other one and the roots of the side were
That's a good question because we're actually, let's see a question like that. So what happens if you simplify all the way down and you have different things in these root signs? So say one of them comes out to be root A and the other one comes out to be root B. Just leave them. Just leave them. You can't do anything with it. So if they're not the same term, it's like adding x's and y's. You would just leave it as x plus y. That's a good question. And I don't think we see a question like that, so that's good to ask. Next one. The 2 in the front, still going to be there. What's the 4th root of PQ? It's still the 4th root of PQ. Nothing changes, right? What is going to happen to the q to the power 5? Love it. You got it. So you're going to have 1q come out, and then you're going to have 4th root PQ, and the 1q is still there. This one works out. We have PQ times q on the inside, which means we have like terms, which means we can combine them together. We have just 1q. I saw that as a plus. 3q times all that junk minus 2q times all that junk is just 1q times all that junk. Q times the 4th root of PQ. It's a lot of variables. You guys aren't used to seeing this many variables, especially right off the top. Okay. We'll do. We can do these. Okay. Before we start, on that challenge question that we just did, remember back in 1.2, we just did it, the circle question, it said, and list your restrictions. And I ignored that because we haven't talked about it yet in this course. Who remembers what restrictions are and why we use them? Yeah, it's almost like a domain and range. It's almost like a domain and range. You're just saying what the variables can't be. So for instance, if we looked at this question right now, just like it is right now. So you see 2 root x minus 3 root 3y plus 5 root x plus 2 root y. That's your question. No restrictions. That means x and y can be any number. Is that actually possible? What if x was negative 2? Can you do the square root of negative 2? No, it's not possible. So what's the rule x has to follow? It has to be positive, or it has to be greater than 0. That's called a restriction. Same thing with y. Y in this question has to be greater than 0, because you can't actually do the square root of a negative number. That's why they've written this. Yeah. It's making it an actual question, like a mathematically sound question by adding this to it. It says x and y are greater than or equal to 0, meaning that they can never be less than 0. Can't be negatives. Correct. They have to put that in. And when you get your tests, those things will always be put in. Especially your diploma. Because the diploma is actually kind of funny, is you can challenge your diploma. So like after you write it, you could be like, that question wasn't fair for whatever reason. And you could challenge, that's why they make these tests so perfectly sound, because you could challenge it and say, well, what if x was negative 2? And if they didn't put the restrictions in, technically you would be right. Which means technically there would be a good solution to this question. So that's why you're always going to see stuff like that on a question. And it really doesn't mean anything to us. We don't ever pick numbers for x, do we? We don't really care. It's just there to make it so it's a good question. So don't let it freak you out. You can literally read it as a separate sentence to everything. And then just focus on the question. So that's what we're going to do. We're going to focus on the question. Combine like terms. What can be combined? So y for the x's. So the 2 and the 5 for the x's, and the 3 and the 2 for the y's. 2x plus 5 root x is just 7 root x. And the y's, negative 3 root y plus 2 root y is just negative root y. Your answer technically should also say at the end of it, x and y are greater than 0. Because that restriction still exists. That's still a part of your answer.
So would you get it wrong if you did that?
Okay, like if it was a written question, maybe dog half a buck. Depends how many apples I eat. If it's a multiple choice question, this will be your answer, and you'll just look at that and you'll figure out that's the answer. And that'll just be attached to all the questions. On our test? No. So I'm not going to give you this, and then as another option, the exact same thing, but with a different restriction. I'm not going to do that. The diploma one day will, but you'll see why. Because the restrictions are actually a really big part of Math 30-1. And here they're not. Oh, I see. Yeah, it'll still stay the same. It'll still exist.
X and y can't be greater, have to be equal to or greater than 0.
Yeah.
How can it be root?
So you choose the number 4y, it goes in. You do the square root of 4, it's 2. And now you're taking that and subtracting 2. Does that make sense? So you would solve this all by itself. And you couldn't solve it if it was a negative y on the inside. That makes sense? Like, it's a separate thing. Yeah, because that is a confusing thing. Because people see minus y, it's already minus y.
So the y is not negative, it's subtracting.
It's subtracting root y. Yeah, the y isn't negative. Okay, over here. That's it. Yeah, these ones aren't that hard. The tricky part is the restrictions. That's all we want to talk about at this part. The restrictions. The simplifying is not too crazy. Which ones can simplify here? Which ones can be combined? The red line and the green lines. The restriction is x is greater than 0. If, crazy land here, the ones that are underlined in green didn't exist. Pretend these don't exist. What would your restriction be? Can x be a negative? Yes. Because it's a cube root. See how they mess with you a little bit? So if those ones didn't exist, you can take the odd root of a negative. You can't take an even root of a negative. It's a lot of restriction talk. Yeah. Okay. Simplify them. It becomes 3 root 2x plus 8 square root 2x. Okay. Oh. Nope, 8. It's 7 plus 1. C, I'm going to skip. Sorry. I'm skipping C just so we can get through this. That's going to try and give you some time for it. It's okay. Do you want to do it? We got some more hard ones coming up. Go for it. Go ahead, trust me. We got 4 more. You can go back and practice if you want. I want to get to the problem solving at the end, so I'm trying to push towards. So let's jump forward and let's do C. Down here. If you look at C right now, is there anything you can combine right now? No, there's nothing you can combine, right? We have root 24 e cubed, we have root 54 e cubed, root 6e. Those are all different terms. And then we have 6e over here by us. Okay, let's simplify it. This first one. How are we going to simplify the root 24 e to the power of 3? Make our perfect square chart. 2 squared equals 4, 3 squared equals 9, 4 squared equals 16. Do any of these go into 24? 4. 4 goes into 24. How many times? 6. So we break 24 into 6 times 4, but the square root of 4 is just 2. So it comes to the outside. If you had, so let's talk about the numbers on the outside. We have 5e on the outside. See here? And we've brought out a 2 now. The 2 multiplies by the 5. Because it's just like 2 times 5e. So it'll change to become 10. Yeah. So 10, and now we have to deal with the e's. Because, yeah, you're right. What's the square root of e cubed? 1e comes out, and the square root of e stays on the inside, right? So, if we were looking at this again, square root of e cubed is the same thing as the square root of e squared times the square root of e. Same thing. So it's just e times the square root of e. Does that make sense? Yeah.
When you have like all of these questions, it'll be like the E3, E5, and like they're all like you see like the pattern, kind of like the 6E. So the 6E is the lowest simplest form. It's the ones that you're gonna most likely like root up with.
Yeah, that's a good way of looking at it. So it's a good like proactive solution of looking at it like we're probably headed towards 60. So yeah, that's probably a good way to look at it. That's where we're headed. Okay, so that means we brought one E out, one E stayed on the inside. What do you think we're going to do with that E when it comes over to the other E on the outside? Multiply the E by the E. What's E times E? E squared. So we have 10 E squared on the outside. And then we're multiplied by the root of 6 was still left over. And the other E was still left over. So 24 broke up into 4 and 6. Square root of 4 came out. The 6 stayed underneath the root sign. E cubed got broken into E squared times E. E squared came out to be 1E on the outside. 1E stayed on the inside. Logan.
Oh, never mind. I thought that was
That's 6. Sorry. Okay, let's do one more. Negative. What are we going to do with 54? What divides into 50? 9. So you're going to break the 54 up into 9 times 6. That means the square root of 9 is 3. 3 times 7 is... 3 times 7 is... If you're looking at that and like, how the hell did he just use 7 to do 21? I'll talk you through it one more time. 54. We broke that up into 9 times 6. The square root of 9 is 3, which came to the outside, but there's a 7 on the outside. So 7 times 3 gave you 21 on the outside. Okay, we have the E cubed again. We know that becomes E. 5. Okay, so then how many E's are coming out of this one? 2, so it's E squared. So E squared comes out, and left on the inside is 6E. Next one.
Yeah, no, I get this. But
Where the E squared came from? Where? Okay.
There's 2. The E squared is 2.
Okay, I'm going to do this one up here too, because this is a better one to look at. Because I don't think you're alone, Jason. I got a lot of work. So the square root of E to the power of 5. People are wondering how we simplified that. I broke it up to be equal to the square root of E squared times the square root of E squared times the square root of E. These all just simplify because the square root of E squared is just E. The square root of E squared is E. And the square root of E is still the square root of E. Which means on the outside we have E squared. E times E is E squared. On the inside we still have 1E. Okay. This next one, can we simplify it? No. Why can't we simplify it? Because nothing divides into the 6, yeah. And E is obviously by itself. So the next one's going to stay the exact same. Plus E squared root 6E. The last one, not 6E. Can you do anything with that? Are you sure? Yeah, you can't do anything with it. You can just have a plus 6E. You can put it to the very front of the equation, you can put it to the back of the equation. Fine. Yeah. Yeah, like it's separate all the way on the outside by itself. Or do you mean you want to combine all these? Yeah. So when you combine everything, the only things you can combine here are these things. Which means that when you're done combining, the plus 6E is still going to be that tag-along friend nobody really likes. Okay. Okay. What's this going to simplify to be? Yeah. There's your answer. Nope.
You haven't done that.
You do nothing with the plus 6e. It's still just there.
How did you get 10?
10e squared minus 21 is negative 11e squared plus another e squared. Yeah. Yeah, just one more. Okay. Which part? That came from this e squared. Square root of 6e. That just came from part of the question right here. Be combined. So you can imagine that there's one of them. So I combine 10 minus 21 plus 1. Combine all the things. Okay. Josh. If you want to do those other ones at home, feel free to attempt the exact same ones. Okay, that's just time to catch that. Here are examples of problems you should be able to do if your goal is to do well in this course. I'm going to talk you through them. It shouldn't be natural to you yet to answer these. If you look at this right now and you go, I can't answer that, that's okay. You should be able to answer it. It's hard. That's why you're learning. You have two squares here. And touching. It's asking you for the perimeter. So the perimeter is all of the outsides added together. Okay.
So the first for point
Good question. So it's giving you the area, not the perimeter. So it's saying the area is 24, which means this times this is equal to 24. So length times width is equal to 24. Normally, we've always given you guys questions where it works out so that your square is, say, area 9, and it's just 3 times 3. Nothing multiplies to be 24. Where the sides are both the same. It's square.
Even if like
That would add up to be 24, but when you do area, it would be 36. Okay, hands up. Hands up if you have a question. Liam. Okay, yeah, that's headed in the right direction. Haley.
if you didn't use like the exact same like form outside, like something else that end up being the same. So you like
6 and 4? No, you're assuming that these are squares. These are squares, so to be a square, you have to have the same length and width. Okay. 4.9, close.
Yeah, it's like
Liam's got the right answer. Liam said take the square root of 24, which is going to be a good hint. Because if you took the square root of 24, and you took the square root of 24, and you multiplied it by the square root of 24, what do you get? No, don't use calculators. Decimals aren't going to help you. Notice that the question says exact value. That means all your questions are going to be needed to be in a radical form. So decimals won't help you. What's the square root of 24 times square root of 24?
I'm just thinking out loud.
Okay.
Just simplify that like we have the whole time, so decide, 2, 3, 3, on the ground.
Yeah, and then the right spot. Yeah. But what I want to know is what's the square root of 24 times the square root of 24? 4. The square root of 24 times the square root of 24 would it equal 24? What if we did this? I'll show you why it equals. You got the square root of 24 in your you're multiplying it by the square root of 24. That just means you have I'm trying to lead you guys through. Just listen. Give me a second. The square root of 24 times the square root of 24. What if I told you x times x? What would you simplify that to be? X squared. So we can simplify that to be the square root of 24 squared. You square root something and then you square it. They just cancel each other out. So that means your side lengths are square root 24 and square root and square root 4 and square root. Okay, what would your side lengths of your 50 square meters be? Square root 50. So square root 50, square root 50, square root 50.
How would you find
That's where we're screwed, right? We look at this and we go, perimeter would be where I'm drawing my red line right now. So right now, it's really easy. We can add up all these sides, but what's this distance right here? And does it matter?
square root of 24? If you square root of 26.
You could
Or
do
you
it.
could take square root of 50 minus the square root of 24.
You could do square root 50 minus square root 24. That would give you that distance. So if they were asking, what is this distance? Square root 50 minus square root 24 would work. That would work. Another way to look at it would be like, you know that this plus that is going to be square root 50. Right? Because that's one whole line, which is just square root of 50. So you can kind of logically work your way through it if you know, I'm going to switch to blue here. Do we know this side length here?
Yeah.
Yes. We know this one here.
Yeah.
Yes. We know this one here.
Yeah.
Yep. We know this one here.
Yeah.
We know this one here. Do we know this one here?
Yeah.
And is it the exact same as this plus this?
Yeah.
We do. It's just square root 50. So instead of adding a square root 24 for this side, add another square root 50 for this inside line. It's a cheap way around what they actually want you to do. They want you to do square root 50 minus square root 24. They want you to go the long way. I'm going to show you the cheap way. If you just put that line there, you know that's square root 50. Come on. So then what is the answer? That's a good question.
Yes, I got 14 root 2.
I think that's close. So we have how many square root 50s? 4. So we have 4 square root 50. How many square root 24s do we have? Plus 2 square root 24. What do we do when we read somewhere at it? You gotta simplify. What chart do you need? Square chart. Okay. 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, but 25 goes into 50. So this one right here is going to change into 4 times the square root of 25 times the square root of 2. See how I broke the 50 up into 2? Plus. Does 4 go into 24? Perfect. What else goes into 24? Anything else? 9? No. 16? No. So we're going to go and take 4 into that. So 4 goes in 6 times, so it's going to change into 2 times the square root of 4 times the square root of 6. And this one's still going to be the last one. The square root of 25 is 5. So 5 times 4 is 25. So the first one is just 20 square root 2 plus, what's the square root of 4? 2. What's 2 times 2? 4. So we have 4 square root. Can we combine those? No. Is that your answer? I said it as if it's not what it is. That's your answer. That's simplified. That's an exact value. It's not a decimal. That's an exact value answer. That's a cheap way through a hard question. When you go home, try to complete 1.3 homework for tomorrow.